Solar Energy by Faye McMillan and Shakira Harper.
Solar energy is formed from nuclear fusion, which is the combustion of smaller atoms to form one large atom. Lost matter from that nuclear combustion is then converted into radiant energy, as you can see here from different wavelengths on the spectrum.
Technology in solar energy varies in different ways. There are solar panels that can be placed on houses or commercial buildings that convert the sun's energy into electricity. A control device changes this electricity, enabling it to power electrical items. Electricity then passes through a breaker box to outlets in the building. Items such as a refrigerator and a lamp, even a microwave, TVs, can plug into the outlets for power. Type of solar energy technology is concentrating solar power plants. Power plants collect energy by generating energy from the sun using a solar steam generator. The steam is then collected and transported to a turbine, which is then transported to a generator. After leaving the generator, the steam is transported to a cooling tower, which is then transported to a gas-fired boiler, and lastly, it is transported to an energy grid. In addition, electric turbines and solar water tanks are also used to collect energy and generate electricity. There are many environmental and social pros of using solar energy. For one, there are no atmospheric or greenhouse gas emissions that will be emitted by using solar energy. This can help with destabilizing global warming and reducing air pollution. In addition, the sun is a great renewable natural source of energy that will never eliminate it. This will also help us stabilize the economy because the sun is free and abundant as opposed to oil. Also, with using solar energy, it will help generate more jobs because we need people to manufacture the solar panels. The social and environmental cons vary as well. The sun is only available during the day, which means that during the night we would have to rely on another source of energy in order to power our items. In addition, some places around the world do not receive a lot of sunlight as opposed to other places around the world. Therefore, we would need to find a way to generate electricity for these places.
The future of solar energy is a broad spectrum today. As you can see, there are a lot of implementations that are soon to come within the next few years. Our concept map contained a lot of ideas and topics within solar energy. As you can see, we talked about solar thermal energy, photovoltaic energy, and how it creates electricity. It enables solar technology from different photons and electrons. Solar technology comes in many different forms, the most common one being solar architecture, where you can see is solar panels, solar water heaters, and anything that can prevent air pollution. Overall, our concept map contains a lot of ideas as a broad spectrum of solar energy. See, the sun is everywhere. An overexposed solar energy is just a nice day.
The Earth intercepts a lot of solar power, 173,000 terawatts. That's 10,000 times more power than the planet's population uses. So is it possible that one day the world could be completely reliant on solar energy? To answer that question, we first need to examine how solar panels convert solar energy to electrical energy. Solar panels are made up of smaller units called solar cells. The most common solar cells are made from silicon, a semiconductor that is the second most abundant element on Earth. In a solar cell, crystalline silicon is sandwiched between conductive layers. Each silicon atom is connected to its neighbors by 4 strong bonds, which keep the electrons in place so no current can flow. Here's the key. A silicon solar cell uses 2 different layers of silicon. An N-type silicon has extra electrons, and P-type silicon has extra spaces for electrons, called holes. Where the 2 types of silicon meet, electrons can wander across the p-n junction, leaving a positive charge on one side and creating negative charge on the other. You can think of light as the flow of tiny particles called photons shooting out from the sun. When one of these photons strikes the silicon cell with enough energy, it can knock an electron from its bond, leaving a hole. The negatively charged electron and location of the positively charged hole are now free to move around. But because of the electric field at the p-n junction, they'll only go one way. The electron is drawn to the n side, while the hole is drawn to the p side. The mobile electrons are collected by thin metal fingers at the top of the cell. From there, they flow through an external circuit, doing electrical work like powering a light bulb, before returning through the conductive aluminum sheet on the back. Each silicon cell only puts out half a volt, but you can string them together in modules to get more power. 12 photovoltaic cells are enough to charge a cell phone, while it takes many modules to power an entire house. Electrons are the only moving parts in a solar cell, and they all go back where they came from. There's nothing to get worn out or used up, so solar cells can last for decades. So what's stopping us from being completely reliant on solar power?